All right, so today we are conducting a really similar investigation to what we did last Friday, where the question was, do things like current and resistance and voltage drop, do they sort of add up in these parallel circuits, or maybe do they remain constant? Is there some kind of other more complicated way to get sort of a total for each of those things? But we're going to investigate that today. So I'll just give a quick reminder and a few sort of tips as you get started with the work today. One, the circuit that I have over here in the simulation on the left looks like yours, but it has all different values for the voltages and the resistances and things. And just as a reminder, if you want to see the numbers in your simulation for those voltages and resistances, there's that little box up in the top right here, the values box, so that'll show me and make sure that I have all the right values. So again, I have a different circuit than what you guys are going to work with in your work, just so that I'm not getting the same answers as you all. But what you should work with is what you have directly in your work with this 20-volt battery, the 40, 10, and 50 ohm resistors connected in parallel. So when we're measuring something like current through these resistors, as a reminder, current is measured by one of these ammeters. Again, that A comes from the fact that current is measured in amperes, which is shown with a capital A. And if I wanted to measure that through, let's say, this top resistor, of course, in your simulation, you'll use the 40 ohm resistor and the 20-volt battery. I'm just using these values here. I'll get rid of those for now. But if I wanted to measure the current here, I got 0.19 amps, so I would just record that in this table, and you could do that for every single resistor in this circuit. Now, to measure the total current, you want to take that to the battery, because whatever this battery is providing to this circuit is whatever that total amount is. So for something like current, I'm just going to put these crosshairs that I used on each of those three resistors, or that I would have. I only demonstrated that on this top one. But I'm going to put that right on our battery here and record this current. So 1.77 amperes is what I would record for my total in my own circuit. Of course, you all are going to get different numbers for yours there. Now, for something like resistance, I would skip that for now. And the reason for that is that we are going to come back to this total resistance at the end once we've gotten our total voltage drops, and once we've gotten the individual voltage drops for each of these. But to measure those voltages, I'm going to take out my voltmeter now, so we don't need the ammeter anymore if I've measured all of the currents through my circuit, through each resistor and through the battery to get my total. And let's take out this voltmeter. And as a quick reminder, we need to get both terminals of this voltmeter on either side of what we want to measure the voltage drop through. So let's say I want to look at the voltage drop through this top resistor. I'm going to take this black terminal and touch it to the wire sort of directly before the resistor. So since the electrons around this would travel from left to right through this circuit, I'm going to put one terminal right to the left of that, and then the other one right after, directly to the right, and I would record this voltage drop of 8.5 volts through this top resistor for me. Again, of course, you are going to get different values for your circuit. And then if I wanted to measure the voltage drop through my battery, or the total voltage drop, to get that sort of bottom row of your table, I'm going to take these two terminals, and I'm going to measure that. And it looks like we got 8.5 volts. You'll notice I just switched the order of these because we are not really going to pay too much attention to signs on these voltages. One important thing to note is that technically the voltage drop on this battery is going to be negative, because it actually, the electrons are gaining energy through those batteries, so a negative drop sort of means that they are gaining that energy. Through your resistors, it should be a positive voltage drop, because a positive drop would mean that our electrons are losing energy. It's weird to think about, but all that we're going to record here is the magnitudes for all of those numbers. So if you get a negative number, that's okay. You'll just write the positive number for your recorded voltage drops and things. Now, to solve for this total resistance, I said we would come back to that after getting our total current and our total voltage drop. So let me take a second to, again, record whatever my total current was. So let's get this written down. We've got a current, and I'll record that as an I is 1.77 amps. Our total voltage drop was 8.5 volts. And our equation that we have is Ohm's Law, which is given to us as V equals I times R. And that's the voltage. Voltage drop is equal to a current times a resistance. So we have two of the three things in this equation. We can solve for the third missing thing. So I'm just going to plug in what we know. We know that the voltage V is 8.5. We know that our current is 1.77. And we do not know our resistance yet. And so if we wanted to solve for this missing R, right now R is being multiplied by 1.77, but I don't want to know what R times 1.77 is. I already know that's 8.5. I just want to know what this R is. So if I want to get rid of that 1.77 or just get R on its own side, I have to divide both sides by that 1.77. I had to do the opposite of whatever it was doing on this right side. And then I plug this in my calculator. Right? So our 1.77s are going to go away, but our 8.5 still has to be divided by this 1.77. And let's see what we get when we divide that. So it looks like we got that our total resistance was 4.8-ish ohms. There are a lot of decimals after that, but I'll just leave this rounded to a decimal place because the next one is 0. So R is equal to about 4.80 ohms. And so that's something that I would notice. But that's how you're going to calculate your total resistance, is you take whatever total current you measure and you take your total voltage drop that you measure and use Ohm's law to then solve for that missing resistance. And then you'll make the decision for yourself on, do those add up? Does it remain the same throughout the entire thing? Maybe is there a slightly more complicated way that total resistance is being calculated? But that's pretty much the exact same sort of procedure that you're going to go through for your investigation today. And then you'll answer the questions for yourselves as to whether or not the current, the resistance, and the voltage add up or not.